we will be doing a problem from the book about the trans effect. Let me move this closer for audio reasons. So, the problem says, and this is from chapter 21, I believe they work out the solution for you. The problem says to use the trans effect to figure out a synthetic root to get cis and trans platinum from a starting material of this platinum with a square planar platinum with a bunch of ammonia groups, and this, the same thing but with chloride groups. So, what is the trans effect? The trans effect says that a ligand will weaken the bond trans to it, right? And this is very useful for stereochemical synthesis because we can use that to control what bonds get broken and formed, right? So, the strength of the trans effect. I drew it up here. There's kind of a hierarchy to it, right? So the weakest trans effect is going to be these at the bottom, and it goes up and up and up, and I ran out of vertical room, so I started going sideways. And this is essentially based on how much do these ligands pull the electron density from the metal towards themselves, right? So on the extreme upper end, you have carbon monoxide, because for that carbon monoxide back bonding, it has the p orbital like pulling from the metal. So let's start out with this starting material, right? The one with all the amides. So I'm going to find my black marker first. Here we go. So if we treat this with chloride, on the first run around, it's going to not care which one it goes to because they're all the same, right? They're all amide ligands. There we go. So now we have the same thing, but with one chloride, right? Now here's where the trans effect comes into play. So remember from our chart over here that chloride has a stronger trans effect than NH3, right? So what that means is this chloride is going to weaken this bond more than these are weakening each other, right? So this is our weakest bond, which means that if we chlorinate it again, this is the easiest one to rip off and replace. And if you look at that, that's our trans configuration, right? So we got the trans. Great. So now I'm going to erase this, and we're going to start with the other one. What happens if we start with this and we treat it with NH3? Well, we remember that it doesn't matter which one it picks because they're all chlorides. So I don't have enough room to do 3 rounds, so I'm just going to replace one of these chlorides with NH3. Now what happens if we treat it again? Well, we remember from before that chloride has a stronger trans effect than the NH3. So let's say it goes across from this chloride. That's not going to happen because there's already an NH3 there. We just mentioned that we're treating it with that. So It can't go here because there's already an NH3 there. It wouldn't be any different. It can't go here because we know that chloride has a stronger trans effect. So this bond right here is going to be stronger than these other two bonds because it's across from an NH3. These chlorides are weakening the chloride opposite themselves far more than this NH3 is weakening this. So it's easiest for the NH3 to attack one of these cis chlorides. And that's how we end up with a cis configuration.